Weak acid, strong base titration problems can be an absolute beast calculation wise because there's so many different ways you approach it depending on where you are in the titration. Generally speaking, the pH is going to start off at whatever the pH of the weak acid alone is. And then as I add base, initially the pH jumps up a bit and then levels off for a while. Not really level, but has a really low slope. And then shoots up suddenly and rolls over towards 14. I need to adjust this line a little bit to make it so that it'll match the data that I have. Okay, it's a little bit ugly. In this region here, in the sort of level part, which I'm going to highlight with green, that area is known as a buffering region. So when I say buffering region, buffering means it minimizes changes in pH. So if I'm adding more acid or adding more base, I don't have the pH changing a lot. Once the buffer part is overwhelmed, the pH will shoot up. We're going to have an inflection point in this graph too. This inflection point is still the equivalence point. It is still when the moles of acid equal the moles of base. But the difference here is rather than being at 7, in a weak acid, strong base titration, you're going to find that equivalence point north of 7. When the graph starts rolling over, it's not going to go above 14. It might approach 14 depending on the concentration of the base. The middle of the buffering region is really an important point that we need to talk about. The middle of the buffering region right here is known as the half equivalence point. Half equivalence point means I've added half as much base as I need to get to equivalence, and I've neutralized half the moles of the original acid. What's super special about this point is it happens at the point where pH equals the pKa value. If you don't remember what a pKa value is, it's the negative log of a Ka value. So for this particular acid, since Ka is 3.2 times 10 to the negative fifth, log 3.2, 10 to the negative fifth, that's going to happen at a pH of 4.5. So this point on the graph, I could note as 4.5. So in other words, I can look at a weak strong titration curve and from it infer what the Ka of the acid is, because I just simply need to find either halfway to equivalence or the middle of that buffering region, and that will help me figure out what the Ka value is. That's an outline of the graph. We're going to go through the titration problem in the next video.